Hello everyone, and welcome to the Logistic Regression with Python lecture part 3. In part 1 of this lecture series, we went ahead and did some exploratory data analysis with some visualizations. In part 2, we went ahead and cleaned our data by dealing with categorical variables and missing data. And now in part 3, we're actually going to train and use a model to predict the classes of whether or not a passenger survived on the Titanic. Let's go ahead and jump back to the notebook where we left off last time. Alright, here I am at the notebook, and here we have our data set. Something to note here is that if you go back to your folder, you'll notice that you had a titanic_test.csv file and a titanic_train.csv file. I'm going to go ahead and treat this training set right here, our train, as if it was the entirety of our data. So I'm going to go ahead and walk through the process of a train test split. In reality, what you can actually do is just do the same cleaning process on the test CSV we have here and use that as your test set, since you actually have two separate CSV files. But in order to go through the process of using scikit-learn's train test split, I'm going to go ahead and treat this train data frame as if it was all our data. Alright, let's go ahead and walk through how you would do that. The first thing we need to do is separate our data into an X and Y. Remember that Y is the column that you're trying to predict, the actual label. In this case, that's going to be the survived column. So I want to predict a 0 or 1 on that survived column. Everything else are going to be the features. So I'm going to go ahead and say X is equal to train drop survived along axis is equal to 1. And now I can go ahead and say from sklearn dot cross_validation import train test split. And I'm just using tab to autocomplete there. And what I like to do is call train test split, do shift tab in my Jupyter notebook so I can see the documentation string, and scroll down until I get to the example. That way I can just go ahead and copy and paste this and save myself some typing. So I'll go ahead and copy that. And then I will paste it in to replace that and put it now all on one line. Okay, so here I have my X train, X test, Y train, Y test. I'm doing train test split. I'm going to go ahead and set my test size to 30%. And I'll set my random state to 101. You don't have to set a random state, but this is just so if you want your results to match mine exactly. Now let's go ahead and run this. Great. Now we have our X test, Y train, Y test, and X train data. Now the next step is to actually train it and predict by creating a model. For logistic regression, we'll go ahead and grab this from the linear model family. So we'll say from sklearn dot linear_model import logistic regression. We'll go ahead and run that. And the next thing we want to do is create an instance of a logistic regression model. So I'll go ahead and create logistic regression. We'll go ahead and call our model log model. And then the next step is actually just training the model. Now if you do shift tab here, it'll give you some more information about the various parameters you can add. But we'll go ahead and just pass in .fit, xtrain, and y_train. We'll run that, and it shows you the default parameters. Those should be fine for us. And we'll go ahead and call some predictions off of this using our xtest dataset. That means we'll go ahead and say predictions equals logModel.predict, and then we just pass in xtest, because we want to predict values off of that x_test. Great. And that's it. We're able to create a model, fit a model, and predict a model in essentially just 3 lines of code if you don't count the train test split. This is actually very reflective of a real-world analysis and machine learning building process. A lot of times, most of your work as a data scientist is actually going to be in cleaning the data and getting the data into an acceptable form for your machine learning algorithm. The machine learning algorithm libraries that you'll be using are actually sophisticated enough and abstract enough that the process of building them will actually be quite simple. So most of your work will be reflected on the cleaning data set. Okay, now let's go ahead and evaluate our model. For classification tasks, scikit-learn has a really nice classification report you can use. You can say from sklearn.metrics import classification report. And the classification report will basically tell you your precision, your recall values, accuracy, F1 score, etc. And that way you don't have to read it yourself off a confusion matrix. I'm going to go ahead and say print. You call classification report, and then you pass in your true values, y-test, and then your predictions. Run that, and then it actually reports back the precision and recall for each class, as well as the average total and the supporting cases for it, as well as an F1 score. Now, if you don't want the classification report and you want the pure confusion matrix, sklearn metrics has that too. You can say from sklearn.metrics import confusion matrix. I'm just doing tab autocomplete, and you can say confusion matrix and pass in the same thing, y-test, predictions, and you'll get the actual confusion matrix to evaluate your model that way. That way, in case you want to actually calculate a very specific value, you can do that directly from the confusion matrix. Okay, these results are actually not so bad considering we're dealing with a smaller set of the data by splitting our training data instead of using the train and test CSVs, but you may want to explore other ways you can increase your precision or recall or accuracy. What you can do are a couple things. Maybe just try using the entirety of the training set versus comparing it to the test CSV after you repeat the cleaning process for the test CSV file. Other things you can do are more feature engineering, such as trying to grab the title of the name and treat that as a feature, such as Dr., Mr. or Mrs., etc. And maybe the cabin letter could be a feature. Maybe that has to do with location on the ship, and that has more information, and also the ticket may have information for you. Go ahead and continue to explore this project as you see fit. There's also, if you go back to the Kaggle link that's actually in the notebook, to the machine learning section, there's some more information on Kaggle.com on how to get started with doing this sort of analysis with Python. So you can check this out for even more ideas, and they actually use a random forest, but since we haven't learned about tree methods quite yet, you may want to hold off on that. But go ahead and treat this as kind of an open-ended ending for you to go ahead and explore the rest of this project and this data, see if you can improve the model further through some more feature engineering. Okay, hope you enjoyed this project. Coming up next is going to be your actual portfolio project exercise, where you'll have to get a new data set and answer some questions and perform some tasks using Python and logistic regression. Okay, thanks everyone, and I'll see you at the next lecture.